In this demonstration, I'll use common commands built into the Windows operating system to test network connectivity. Here in my Windows command prompt, I can issue the ipconfig command to show me my network interfaces and some basic IP addressing information. So here I can see I've got a network interface called the Internet. I've been assigned a link local IPv6 address with an FE80 prefix, which is normal. That is always there, and it's good. That's used for discovery of devices on the IPv6 network. Then I've got an IPv4 IP address along with the subnet mask. In this case, the first three numbers are 255, which means the first three numbers of my IPv4 address identify the network. And the last number is my address on that network, in this case, .14. Then I can see the default gateway, and it's important that this be correct. It needs to be on the same subnet that my machine is configured on. In this case, that's subnet 192.168.0, because if the default gateway is configured on another subnet, how could you get to it without going through the default gateway? The default gateway is the router. It's the door out to get out to other networks. But I can also clear the screen here and run ipconfig/all. When I do that, I get a lot more information for each network interface. So I'm going to scroll up here a little bit because I'm interested in my internet connection. I can see I've also got the physical address listed here. This is my 48-bit hexadecimal MAC address, the address assigned to my network interface card. I can also see that DHCP is enabled for this network interface. So in other words, I don't need to manually configure TCP/IP. I can see when the IP configuration lease was obtained and when it expires. Shortly before the expiration, my machine will try to renew the same IP configuration. However, if I don't like that and I'm having problems, I can do that whenever I wish. So I could do an ipconfig/release. When I do that, it means I'm releasing any of my DHCP IP addressing. And notice for my connection, the Internet, I no longer have an IPv4 configuration. Now, if I type in ipconfig/renew, then it'll go out and talk on my network interfaces and try to find a DHCP server that will respond back with an IP configuration. And after a moment, we can see that we've got our IP configuration back. Another command that's going to be important for troubleshooting is the old standard ping command. I'm going to go ahead and ping a name. I can also ping IP addresses. Here I'm going to ping www.hbo.com. Now notice, we know that DNS is working because it is resolving the name to an IP address. We're just not getting a ping reply. We're not getting a response back. When this happens, it means the host is probably there, but it's probably firewalled to block ICMP traffic. When you use the ping command, you're using ICMP as a protocol. Now to verify that that's true, I'm going to open a web browser window and see if putting in the same name pops up the web page. Now sure enough, when I do enter www.hbo into my web browser address bar, it does pop up the web page. So when it comes to troubleshooting, we need to be able to eliminate what the problem is not sometimes. And we know that the problem here is not that web server is down. We're getting a response. More than likely it's firewalled, which is why our ping command didn't return a response. We can also use the traceRT command in Windows, traceroute, to trace our path through routers to get to a target. And we can specify either a name or an IP address. So for example, I'm going to go ahead and trace a route to www.cnn.com. Ping and traceroute both use the ICMP protocol. So if that is being blocked on any routers or on the target, then at some point we won't be getting a response back from a router. What you're seeing happening here is it's going through each router and returning back sampling of the response time. Notice that generally the response time will increase the farther away we get to target routers before we actually end up getting to our target, which in this case is www.cnn.com. But the great thing about this command is we know how far down the line we're getting if we're having connectivity problems. And here we can see that we've got a completed trace to our target, which is listed as 151.101.117.67. So all of the routers in the path are responding, and so is the target itself, which should tell me then I should be able to ping that by all rights. So ping www.cnn.com. In this case, sure enough, it is responding to my ping requests. The next command we'll take a quick look at is the name server lookup, or NS lookup for short, which is used to test our name resolution from friendly name to IP address. You could also test vice versa if you really wanted to. So I can see the name and IP address of the DNS server I am connected to. And if I just want to test, for example, a friendly name like www.hbo.com, we can see that we are getting non-authoritative answers. Non-authoritative means our DNS server doesn't actually hold those records. It had to query another DNS server. And notice here we've got actually 3 IP addresses associated with that name. Usually that means there's some kind of load balancing in place to handle a very busy peak workload when that's required. At the same time, I can also change the type of DNS record that I want to query. What we've just queried is what's called an A record. We give it a name, it returns the IPv4 address. I'm going to set type equal to MX for a mail exchanger record. So now, if I were to type in, let's say, whitehouse.gov, it'll return mail exchange records related to that DNS name. So we can get a little bit of information about servers that handle SMTP internet mail transfer. All of these commands can serve to help us troubleshoot when we're having some kind of a connectivity problem. Whether it's a wired network or wireless doesn't really matter in this context. These commands will work the same.